Now we'll solve the problems from exercise 1b on irrational numbers. Question number 1. State whether the following numbers are rational or not. Root 3 minus root 2 whole square. So this is in the form of a minus b whole square. So we can expand this. A square, that is root 3 square, plus b square, that is root 2 square, minus twice ab. A is root 3 and b is root 2, that is equal to 3 plus 2 minus 2 root 6. Root 3 multiplied by root 2 is equal to root 6, and this is equal to 5 minus 2 root 6. We can also write like 5 plus minus 2 root 6. So in this number, you see root 6 is an irrational number and 2 is a rational number, and the product of a rational and irrational number is always an irrational number. This part is the negative of an irrational number, and negative of all irrational number is also irrational numbers. So this is irrational, but 5 is rational number. The sum of rational and an irrational number is always irrational number. So you have to remember this thing. The product of a non-zero rational and an irrational number is always irrational, except 0, because 0 multiplied by any irrational number, root 3 is equal to 0, which is a rational number. But except 0, the product of any rational number and an irrational number is irrational number. Also, the sum of a rational and irrational number is always irrational. For example, we got this one, 5 plus minus 2 root 6. This is the sum of a rational and an irrational number. So this is irrational number. And this question number 6, this is root 7 whole square, and denominator is 6 square multiplied by root 2 whole square equal to 7 divided by 36 multiplied by 2 equal to 7 divided by 72. So this is in the form of p upon q, where both p and q are integers and q is not equal to 0. So this is a rational number. Question number 3. State in each case whether true or false. So root 2 and root 3 both are irrational, but the sum of these two irrational number is not equal to root 5. And this 2 root 2 plus 2 equal to 6. This is true because this is 2 multiplied by root 4 is equal to 2 plus 2. So this is equal to 6. And this 3 root 7 minus 2 root 7 equal to 7. That is true. This is like 3x minus 2x is equal to x, where x is root 7 in this case. 2 upon 7 is an irrational number. This is false because this can be expressed in the form of p upon q, the rational form. 5 upon 11 is a rational number. This is true in the form of p upon q. All real numbers are rational numbers. This is false. Union of rational and irrational numbers is real numbers. So all real numbers are not rational numbers. Rational number is a pure subset of real numbers, but all real numbers are not rational numbers. Some real numbers are rational numbers. This is true. Since the union of rational and irrational number is real number, so some of the real numbers are rational. Question number 4. Given universal set is, so this is a set which is said to be the universal set, and from this we have to find the set of rational numbers. Suppose the set of rational numbers is represented by q1. So there will be minus 6, this one, minus 5, 3 upon 4. This can be expressed in the pure fraction. Then this one is minus root 4 because root 4 is equal to 2, which is a rational number. Minus 3 upon 5 is a rational number. Minus 3 upon 8 is also a rational number. 0 is integer as well as this is a rational number. 4 upon 5 is a rational number. Then 1 is an integer and also a rational number. This is 1, 2 upon 3. This can be expressed in the form of P upon Q. Root 8 is not a rational number. 3.01 is a rational number. 3.01, this is terminating decimal. Pi is not a rational number. Non-terminating, non-recurring decimal. And this is a terminating decimal, 8.47. So this is the subset of the universal set, and this set is the set of rational numbers derived from the given universal set. Now the set of irrational numbers, suppose the set of irrational numbers is represented by Q1 dash, and this is equal to all irrational numbers from here. Root 8 is an irrational number, then pi is an irrational number. These are the irrational numbers. So this is set of irrational numbers. Then set of integers, suppose the set of integers is represented by I, the set of integers. So here, from here you can see minus 6 is an integer. Again, minus root 4 is an integer because root 4 equal to root 2. 0 is an integer. 1 is an integer. So this is the set of integers. Now set of non-negative integers, suppose this set is I2 is equal to, you see the non-negative integer, there are types integer negative and positive, but there is neither negative nor positive, that is equal to 0. So if we say non-negative integers, then this include 0, 0 and 1. 1 is positive and 0 is non-negative integer. Now question number 6. Prove that each of the following number is irrational. So these are same type of questions. We'll do this one. Let 3 minus root 2 is equal to x rational number. Let us find the square of this rational number. Root 3 minus root 2 whole square is equal to x square on both the sides. So this is equal to a minus b whole square. So 3 square plus root 2 whole square minus twice a and b is equal to x square. So this is equal to 9 plus 2 minus 6 root 2 is equal to x square is equal to 11 minus 6 root 2 is equal to x square minus 6 root 2 is equal to x square minus 11, and therefore root 2 is equal to x square minus 11 divided by minus 6, or this is equal to 11 minus x square divided by 6. Now here you see 11 is a rational number. X square is also a rational number because we have assumed that x is a rational number. So 11 minus x square is a rational number. This number is rational number. So we can say 11 minus x square, this is rational, divided by 6 divided by another rational number is a rational number. But left hand side root 2 is an irrational number. So in the left hand side we get an irrational number which is equal to a rational number and which is impossible. So we get an impossible thing because we assume that 3 minus root 2 is equal to x is a rational number, which is not true. So this is the proof that 3 minus root 2 is an irrational number. Similarly, we can prove for all the problems here. Number 7, write a pair of irrational numbers whose sum is irrational. Okay, irrational numbers, say root 2 plus 3, 1. Another is say root 3 plus 2. Sum will be 3 plus 2 is equal to 5 plus root 2 plus root 3. So this is an irrational number. So we can take any other example, even root 2 plus root 5. This is an irrational number. Write a pair of irrational number whose sum is rational. 5 minus 2 root 3. This is an irrational number. Now let us take another irrational number, 3 plus 2 root 3. So their sum is equal to 5 minus 2 root 3 plus 3 plus 2 root 3. So this 2 will get cancelled and we'll get this is equal to 8, and this is a rational number. Question number 9. Write a pair of irrational numbers whose difference is irrational. So 3 plus root 2 minus 3 minus root 2. This is irrational, this is also irrational, and their difference is equal to 3 plus root 2 minus 3 plus root 2. This 3 get cancelled, and this will be twice root 2, which is irrational. Number 10. Write a pair of irrational numbers whose difference is rational. 3 plus root 2 minus 5 plus root 2. So these are two irrational numbers, and their difference is 3 plus root 2 minus 5 minus root 2. So we get minus 2, and this is a rational number. Write a pair of irrational numbers whose product is irrational. 2 plus root 3 multiplied by 3 plus root 2. So the product is 2 into 3 is equal to 6. 2 into root 2 is equal to 2 root 2. Root 3 into 3 is equal to 3 root 3. Root 3 into root 2 is equal to root 6. 6 plus 2 root 2 plus 3 root 3 plus root 6. This is irrational. We can take any other simple example. Root 2 multiplied by root 5 is equal to root 10. This is also irrational. Write a pair of irrational numbers whose product is rational. Now let us take 3 plus root 2 multiplied by another irrational number, 3 minus root 2. So this is a plus b into a minus b. So this is 3 square minus root 2 square is equal to 9 minus 2 is equal to 7, and this is a rational number. Similarly, you can take another example, say root 2 multiplied by root 8. This is equal to root 2 into root 2 into root 2 into root 2. So this is equal to 2 into 2 into 2 into 2. So this is equal to 4. This is a rational number.